Hey everyone, welcome back to KBS Technocraft Python tutorial day 10. Today we are going to explore NumPy module in more detail. In this, today we are going to cover how to create NumPy array using the functions guide array zeros, one, full, arrange, and line space. Then we are going to learn manipulation of the NumPy array, for example, using indexing, resorting, concatenation, splitting. And then we are going to learn mathematical operations on NumPy array, for example, basic operations that is called addition, subtraction, multiplication, and division. And then we are going to learn aggregation functions like sum, mean, standard deviation. And the next, we are going to learn universal functions like applying sine, cos, and exponential, how you can use it. And then we are going to learn linear algebra like matrix multiplication, decomposition. And then we are going to proceed with the broadcasting and then performance optimization using vectorization. And then we are going to learn few advanced topic like mask array and structure array. So without wasting any time, we will go on to the code, and I have opened the Visual Studio, and I have installed the NumPy. But before we dive into today's video, I just wanted to take a moment to invite you to join my channel KBS Technocraft. If you like what you see, please consider hitting the subscribe button and turning on the notification bell. Okay, so before we jump onto the code or start coding, I just want to know that if you have not installed the NumPy and you don't know how to install NumPy, I will add the link into the description box. Please refer that. It's very simple if you know how to install pip, and then using pip you can use the command and you can install it. So uh, to install numpy, what you have to do, you have to go on terminal, or you can use command prompt as well and then try to install it. If pip is installed, it will try to install it on your system. Okay, so I hope you will be able to install it. If not, then put a comment in the comment box and I will try to answer it, and I will try to provide some link which will support you to uh, install this numpy. Okay, so now I have installed that numpy on my system, and then what I'm going to do, I'm going to import it, import, and then numpy, and then I'll give some alias name as a NP, and then I'm going to first create a very simple array. So a, let's say consider a is a variable which will store the array value, and then array, and then I will pass a simple list here. So 1, 2, 3, 4, and 5, and I will try to print it. Okay. And we could say this one dimensional array is getting created. Let me run once again. You will be able to see this result here. Okay, I miss. So I'm going to import numpy array, numpy as py. You can give alias name, and then I'm declaring a array variable a equal to then py dot array, and then I'm going to pass list here 1, 2, 3, 4, and then I'm going to print it. I'm going to print it, and then I'm going to run this code. So if I run this code, you'll be able to see this array is created. Now let's say consider you want to create a multi-dimensional array. To create a multi-dimensional array, what we require, we need to pass the two list here. Let's say consider here and here, and then I need to close it. So here, if you see, the first row of that array will be this 0, 0, 0, 1, and then 0, 1, then 1, 2. like this. So if I run this code, you'll be able to see this array is two dimension created. Similar way, you can create a multiple dimensional array here by using this. Okay. Now we will see how to use zeros and what is the function value for this zero. So why we should use zero? So let's say consider you want to create a array using this zeros. So what I'm going to do, I'm going to use zeros, and then I'm going to pass some value over there. So let me pass that value. You can pass any value. So I just pass 3, 4, and then I'm just trying to print it, and I'm just trying to print it. So when you run this, you will be able to see that this all, if you see this all, this multidimensional array, that is the 3 by 4 array, where all the elements of this array is getting initialized with 0. So this 0 will create an array for given dimension, and it will initialize to 0 to all element. Similar way, we can see that once, when you create once, what will happen? So it will initialize with 1. So for example, let me here type once and try to run this same code and run it. If you see, all these elements are getting initialized by 1. So zeros means it will zeros all the element. 1 means it will make it 1 to all the elements for a given dimension whatever you are passing. Okay. Full, so you can use full also, or that means where you are defining the dimension first, and then you are going to define the second parameter. So let me type this code, and then we will see. Yeah. So this is called full. Here we are having a array dimension as the first, and then a number we are passing into the second parameter. When we run it, let me clear this, then you'll be able to see this, what we are trying to get it. Let's say consider 0 and 1. When you use it, it will, irrespective of all the elements, it will be able to change to that particular value. But other than the 0 1, if you want to initialize all the elements with a given number, then you have to use full, where you are going to initialize all this matrix 3 cross 3 matrix with the 7. If I post 3 cross 4, you will be able to get that 3 cross 4 matrix initialized by 7. So if you see this, you are able to get it. Okay, arrange, similar way arrange, where you have 3 parameter. So it will range of value, it will take it, and then it will do that. Let me type it. We will see arrange. So I'm going to use this arrange, and then 0. Okay, if I print it now, let me clear this console box. If I print it, we'll be able to see that 0, 2, 4, 6, 8. Okay, so what it arranges is the 0 to 10, and then the increment whatever if you see this parameter, this 3. So it's basically is giving a number which is incrementing from 0. For example, if I give it here 4, then you will be able to see 0 4. If you see 0 4 8. Why is 8? Because 8 is, if you add one more time 4, it will become 12, and it will go beyond this range. So if I make it 16 here, then let me make it 13, then you will be able to see 4 elements here. So you are able to see 0 4 8 and 12. So this is the range from where is I start. If I start from 2 and try to print it, then let's say I will run it. So it's start from 2, 6, and 10. Because after 10, if he's add 4, it will become 14, which is greater than 13. That's why it's not displaying here. Okay. So let's move quickly on the lin space. So we will use lin space, and this also take three input parameters. So if I run this code and clear the console, you see there 1015. So it's a 0, 25, 50, 75, and 1. So what does it do? It's a create a pie part between 0 to 1 and display it. So if I make it 6, then it will give you the 6 part here. This is from 0, 0.2, like this it will be. If I make it 10, it will give you between 0 to 1, it will consider 10 parts, and it will give me the 10 parts. That's how it is going to give you. Okay, so I hope this line space is clear. You will be defining from where is the start, and then you are start defining the max limit, and then you are going to define that how many line space you want. For example, how many parts you want to divide it at range. So it will divide it in that range. Okay. So let's move to the next one. Next one is random. So if you want to create an array where you want to define the random value to all the elements, in that case you will use the rand. So I'll use it here. And before running, I will clear it. Okay. Basically here it's a random dot rand. So basically it's inside the object class properties. So you will be using like this. There is some spelling mistake. I will just try to correct it. It's a random spelling. Okay. And if I clear it and run it, I'll be able to see this. All the 3 class 3 is random number is assigned. Okay. So this is for when you want to define some initialize that array element with some random value. You can initialize it. Okay. Okay. So this is about how to create numpy array. The core numpy is the num array and n-dimensional array. A n-dimensional array is a collection of elements of the same type that can manipulate effectively. So now we will move on to the next section, which is called manipulating using numpy array. So how you can manipulate this numpy arrays. So for example, if you want to do some indexing or reshaping, that you can do that. So let me create a array which is two-dimensional array, and then we will try to do reshape. So I will clear the console, and then I will try to create a two-dimensional array. So first let me clear it, and then I'm going to create a two-dimensional array. So So here what I'm doing it, I have uh, imported to NumPy as NP, and then I'm creating an array as simpler with the previous article which we discussed, and then we are doing reshape 1 to 4. So when we run this code, I'm trying to print it reshape amount. So if you see 1, 2, 3, 4, so it's going to reshape all these four elements in this array. So this is how it is. If I put 1, 2 and run this code, is giving error because the number of elements are 4 and you cannot reshape it to that. So let me input var and run it 5, it will give me error. So if I put 1 4, then only it will give me the result, because the number of elements are 4, and that's why it's able to reshape it. Let's see the other example, and that in that we are going to transpose a array. So same array which we have created, we are going to transpose it and print it. So let me use that transpose array, and that can be defined on that array. So for example, if it's is there, and then I'm going to transpose it. So what I have done, I created this two-dimensional array, and then I use the transpose method, which is a part of this numpy, which we can apply on a particular array, and then we can print it. This for time being I'm printing it. So if you see, this is transposing. If you see, instead of 1 2 3 4 is coming 1 3 2 4. That's how the transpose is working, and that's how the transpose works. Now concatenating the two array, for example, if you want to concatenate array into that previous array what we have a declared. So let me do that. So we have a two-dimensional array, and then we are doing that concatenation. So np this array, we are creating a second array which is e, and then we are concatenating a is the first array, and e, okay, and then we are trying to print it. We will try to print it. So if you see, it's concatenated to 1 2 3 4 5 6, like this is now if you want to, let's say, consider you want to create one more array and you want to concatenate it. So for example, let me make it 7 8, 7 and 8, and I will give this name as a k, and then I will put it here, okay, and run this code. You are able to see that 7 and 8 are concatenated. So that's how the concatenation using numpy array, we can do that. Okay, you can split it. For example, if you want to split it, you can split it any array. So for example, in the previous case, we will do same thing. We will concatenate and we'll try to split that array. So let's see, I declare a array. The first one is, and then what I'm doing, I am deleting, and then what I'm doing, I'm splitting here the f, whatever the output is coming after concatenation, I'm splitting it. So let me run it, and when I run it, you'll be able to see that a split is happening here. Array split is working. So that's how you can split the array here. Now we will try to look on other sort. So for example, if you want to sort a array, then you can use sort method and you can sort it. For example, let's say consider I'm declaring array and I want to sort it. So in that case, I will use sort method. For example, I declare a array, and then it's, if you see, the sorting order is not correct. So in this declaration, and then we are sorting it and we are printing it. If you sort it, then it will display you 1 2 3. Let me clear this console and run it. I run it here, you can see 1 2 3 4 5 is there. Okay, so that's how the sorting, the sort functions work for array. Okay, now we will see one more functions on mathematical operations, that is, we will move on the basic operations. So these are the mathematical operations which we can apply on arrays. For example, if you have a two array, you want to add it. So how to do that? We will try to create two array, and then we are going to apply a addition or plus operation on that. So let me create two array here, and then declare this. So here, what I have done it, I have created array 1, array 2, and both are two-dimensional array, and then I'm trying to add it. So what I did it, a plus b I had did it. That means directly, if you see here, directly we are performing the operations on the array, not the individual value. So if you run this, you'll be able to see this is happening. This is, so what we have done, we are trying to add this value. So if you see here, 1, this 1 plus 5 6, 2 plus 6 8. So first row of this array is, if you see, first dimension is 0 0 and 0 1 is this. Then 3 4 and 7 8 is running adding. So 3 plus 7 10 and 4 plus 8 12. So that's how this 10 and 12 is coming. So that's how you can apply plus operation on arrays. Okay, so let's see now. You want to apply the subtraction. So let's do subtraction and try to print it. So what I'm doing, I'm trying to apply the subtraction on these two arrays. So B and A is there, and then uh, what I'm doing, I'm doing the subtraction from B to A, which the result is stored or defined into the D, and D we are printing it. So D will give you the subtraction of A from B. So if I run this code, I'm able to see this 4 4. Okay, let's say consider if I give A minus B, then should give me the minus result, the minus minus. So if you see minus 4 4, because this is minus 4 high, if I subtract 5 from 1, it will be minus 4. That's why it's minus 4. So that's why it's coming minus 4. And if I subtract 6 from 2, then minus 4 will come. That's why it's coming minus 4. So let me clear it, and then we will try to do multiplication on the arrays. So to multiply, we will simply put a star b, and we'll see that how does it works. So when you apply a star b, you will be able to see this multiplication is working. If you see 1 multiplied by 5 is coming 5, 2 multiplied by 6, so it's coming 12, and then 3 multiplied by 7 is coming 21, and then 4 multiplied by 8 is coming 32. That's how this multiplication works. It's very simple. I'm not going in more detail, but I think that's how it's division. It's a similar way division also you can apply. So I will try to write a division on these two. So I'm going to divide b by a and store that value in one variable f. I'm dividing b by f, b by a, and running it. So if you see here, this all division is coming. If 5 divided by 1 is 5, if 6 divided by 2 is a 3, but this 7 divided by 3 is come 2.66, and then I know 8 divided by 4 is come 2. So that's how automatically this float number, or you can say decimal number, is coming here. Okay, now let's move to the next section, which we can say aggregation function. Aggregation means when you apply a sum on array, how you can sum, mean. So we will try to cover couple of, and then you can refer the link defined in description box, where I have mentioned all the examples which you can use it for your reference purpose. Here we are going to sum and mean. We will try to use sum and mean. So I'm going to define to array. Let's say I have one array, and then I'm planning to sum all the elements of this array, and then that's how I'm doing. So what I created array, two-dimensional array, and then I'm applying np.sum on that particular array, and then I'm trying to define a variable p where this all sum value will be stored, and then I'm printing it. So let me clear it and run it. If you see, then if I define here 3 and here define is 6, what I'm doing, and then you will be able to see this result is coming 19, because if you add this all, it will come 19. Now we will try to apply mean and see that how this means works. So mean is, I will declare array, same array, I will use it, and I will try to apply the mean. So the two-dimensional array which we have defined it, we will use for mean, and we are going to use np.mean. So let's say here, so here, and then we are going to print it. When we are running it, we will be able to see mean. So it's take the mean of all these elements of this array. Okay, then similar way we can calculate standard. Let me try to calculate it. And then is std method name is std, where you can apply it. So I'm just trying to apply a standard np.std, and then I'm passing the array. All these aggregations functions are required to pass array, so you declare array and pass those array, and then you can print it that value, whatever aggregation value is coming. So if you see, standard deviation value is coming like this. Okay, so now we will quickly move into the next section, which is basically called universal function. Universal functions are function like square, exponential, log. So we will try to cover few of them. So let's say we will try to cover square. When you want to apply a square on array, so that means all the elements in that particular array will get square. So I'm running here this array defined 1 2 3 4, which contains 4 elements, and then I'm using this universal function called square, uh, and then I'm passing that array, so I will be able to get the square of all these values. So if you see here, square root, basically this is a square root, so you are able to get the square root for this. So for example, if I 4, then 9, and then 25, and we get 2, 3, and 5. So if I run it, I should get it 2, 3, 5. So if you see, it's giving 2, 3, 5, the square root of this. Okay, so that's how you can calculate a square root. The similar way you can calculate exponential. So for example, this, and we are going to calculate exponential for same array, whatever is there, and then it's a similar how you have to use exp function, where you are going to pass this array, and then it will be calculating exponent for all this element, and it will be displayed. So if you see here, it's calculated and it's a displayed there. Let me clean it, and then I will move to the next section. Okay, next section is called linear algebra. When you want to perform something like a metric multiplication and decomposition, so we will take one example, and we will declare two 2 cross 2 arrays, and then we will try to apply the multiplication of that. So here I'm going to declare two two-dimensional array, and then I'm going to apply the matrix multiplication for that. So what I have done it here, I have created two array two-dimensional. One is 1 2 3 4, another one is 5 6 7 8, and then I'm trying to apply uh, matrix multiplication using mul, that is the matrix multiplication function name, and then you pass one array uh, as the first object, and second array is the second object, and then you will try to print it. I'm trying to print it, so this will give me the matrix multiplication result. So if you see here, 19 22 43 44, it will give me the matrix multiplication result of this. This is mathematical, so if you know matrix multiplication is okay, but just for understanding, this is how the matrix multiplication works. Okay, now we will see what is the broadcasting. When you want to apply, basically when you want to apply a operation of two arrays where their dimensions are different. For example, if you want to apply a addition with broadcasting, that means you want to apply a addition on one which is 3 cross 3 dimensional array, and other is 1 cross 3 dimensional array. In that case, this mechanism in numpy array is called broadcasting. So let's consider we are going to create one 3 cross 3 dimensional array. That is, the first array is 3 cross 3 dimensional array, and then the first one, the second array, which is called b, is 1 by 3 array. That means it contains three elements in this, and then we are going to apply the addition on there. So if you see the dimension, one is having 3 by 3 and one is having 1 by 3. So we will try to apply this addition operation, and see the what is the result of this. So when you apply it, what will happen, this the second array will get added for each row of the a. So for example, if you apply it, if you see 11 22 33, so what will happen, if you see, if 1 2 3 is getting added 1 by 1 plus 10, 11, 2 plus 20, 22, 3 plus 30, it's become 33. So, and then second, 4 plus 10, 14. Similar weights keep adding that. This is very great feature which is there in NumPy, where you can apply the addition multiplication on the different dimensional array. So I'm going to apply one more operation, that is multiplication, and we'll see that how does it works, and then we'll move to the next section. So this is multiplication, where we are applying the multiplication a by b, a multiplied by b, and then I'm going to clear this console and run this. If I run it, I'm able to see this result is a similar way. 1 into 10, 10, and then 2 into 40, 20, 40, and 3 into 90, 3 into 30 is 90. So that's how it's working here. Okay. Now we will move to the next one, and then uh, you can define a broadcasting basis scalar. What does it means? That you can do, let's say, consider in there is an array where you want to multiply by 2 in all the elements of the array. So what I'm going to do it here, I'm going to apply on array 1, that is a, and multiplied by a scalar, that means 2. So what will happen, it will apply the multiplication of 2 for all the elements into the array. So let me run this. See here, it's a multiplying 2. So this all element of this 3 class 3 array is multiplied by this particular defined scalar. So that's how you can use this numpy behavior like broadcasting over there. Okay. Performance mm, optimization is very big topic which I am going to cover in very short, and if I get a chance in future, I will create other video for this. So I will create a sample where we will try to understand how we can perform the vector addition here. So I will create an array, and then I will define a vector addition for that. So this, I'm going to clear this and write other program here and then use it. So here I have it two one-dimensional array where 1, 2, 3, and 4, 5, 6, and then I'm going to define that simple vector uh, addition on this. So I will do clean and run it. Okay, so if you see, each element of the corresponding index is getting added here, 5, 7, and 9. So this is how this vector addition works. Similar way you can define multiplication and other operation as well. Okay, so let's move on the advanced topic, where we will see what is the mask array and how we can mask it. So this is very advanced, again it's also a big topic, and I'm trying to cover very few points over here. So I will go with simple one mask, and then we will see how we can use this masking concept using this. So we will try to create one example here, and then I will go through this. Okay, so what I have done, I have imported here numpy np, and then imported uh, two instances of this. Okay, so then I have a dot array, and then we are mask a equal to 9. So what this line do, basically wherever this values is there, those positions is going to mask it. So that's why a, we have a is this array, and then mask whatever we have defined it, the value which we want to mask it, and we call the mask array. So in that case, if you see the values minus 99, 999 is available two places. So these two places are going to be masked. For example, when I run it this, you will be able to see this values wherever 999 is there is getting masked. Okay, let's say consider if I try to mask one. Let's say consider one. So it will mask only one wherever one is there. So if you see, this only one is getting masked. That's how the masking concept works. So thanks for watching. If you enjoyed this video and want to see more like it, please consider subscribe to my channel by hitting the subscribe button, and you will notify every time when I upload a new video. And don't forget to hit the notification bell so you never miss the thing. Your support means a lot to me and help me to create more content that you love. So if you have not already, hit the subscribe button and join KBS Technocraft community. Thank you.